Good morning, everyone. Myself, Harshil Deshpande. I am from section A2. My roll number is 63, and this video is for quantum computing teacher assessment 2. So, my topic is about eigenvalues and eigenvectors of a matrix, Hermitian matrix, and unitary matrix. So, here we will first learn about the eigenvalues and eigenvectors of a matrix. So, basically, eigenvalues and eigenvectors are the fundamental concepts for representing how a linear transformation or a square matrix act as a vector. An eigenvector is a non-zero vector that does not change in direction when the transformation is applied. It is only scaled. The eigenvalue is a scalar factor by which the eigenvector is stretched, compressed, or reversed. So we will calculate that how to find eigenvalues and eigenvectors. So this is the method. Let we take a matrix a 2 cross 2 matrix, which is 1 1 9 1. So to calculate eigenvalues, we have to take a determinant of A minus lambda I matrix and compare it to 0. So here this will become 1 1 9 1 minus lambda 0 0 lambda, and this determinant will equals to 0. And after the subtraction, it become 1 minus lambda 1 9 1 minus lambda. The determinant will equals to 0. So when we take the determinant, so it will become 1 minus lambda into 1 minus lambda minus 9 into 1 equals to 0. So 1 minus lambda plus lambda square minus 9 equal to 0. So it will turn in the equation lambda square minus 2 lambda minus 8 equal to 0. So we have to factorize it. So after factorization, it will use us two values of lambda, which will lambda equal to minus 2 and lambda equal to 4. So these two are the eigenvalues for the matrix A. So for eigenvectors, here to calculate eigenvector, we have to do A minus lambda I into lambda vector and compare equal to 0. So here we will take lambda equal to minus 2. So it will become, so the equation was 1 minus lambda. So it will become 1 minus of minus 2 will become 3. So 3193 into lambda vector equals to 0 vector. So here for lambda equal to minus 2, it will become minus 1 3 2 cross. So for lambda equal to 4, it will become 1 minus lambda. So it will turn in minus 3 1 9 minus 3 into lambda vector, which is equal to 0 matrix. So the eigenvector for lambda equal to 1, lambda equal to 4 will be 1 3 8 2 cross 1 matrix. So this is all about the eigenvalues and eigenvectors. So now we will learn about a Hermitian matrix. A Hermitian matrix is a square matrix with complex entries that equals to its own conjugate transpose. This means its diagonal elements are real and its off diagonal elements are complex conjugate of each other across the main diagonal. So the property of Hermitian matrix is A equal to conjugate transpose of A, which is also equal to A dagger, and which is also equal to adjoint of A. So if this property is true, then we can call the matrix as Hermitian matrix. So here we will take one example. Let a matrix A 2 cross 2 matrix, which is 2 1 plus I 1 minus I 3. We have to check whether this matrix is Hermitian or not. So we have to calculate the A dagger, which is equal to conjugate transpose of A or adjoint of A. So first here we will take conjugate of A, which is equal to 2 1 minus I 1 plus I 3, which is a 2 cross 2 matrix. And then we will take transpose of conjugate of A, which will become 2 1 plus I 1 minus I 3, also a 2 cross 2 matrix. So here transpose of conjugate of A will become A dagger equals to 2 1 plus I 1 minus I 3 a 2 cross 2 matrix, and you can see here A and A dagger are same, so the property here is true. So A dagger is equal to, and you can see the A transpose and A in both the diagonal elements are real, and the off diagonal elements are complex conjugate of each other. So the properties of Hermitian matrix here are true. So we can say matrix A is an Hermitian matrix. So now we will know about the importance of Hermitian matrix. Hermitian matrix is crucial because their real eigenvalues correspond to observable physical quantities in quantum mechanics, ensuring that measurement outcome are real numbers. So this is all about the Hermitian matrix. Now we will move on unitary matrix. A unitary matrix is a complex square matrix whose inverse is equal to its conjugate transpose. This is mathematically expressed as h dot adjoint of h equal to adjoint of h dot h equal to I. We can also say it as h dot h dagger equal to h dagger dot h equal to I, or h dot conjugate transpose of h equal to conjugate transpose of h dot h equal to I. So this is the property. If it is true, then we can call it as unitary matrix. So we will here take one example. So let H matrix equal to 1 by root 2 and a true cross 2 matrix 1 1 1 minus 1. So we have to calculate H dagger, which is equal to conjugate transpose of H. So here conjugate of H is equal to 1 by root 2 1 1 1 minus 1, and the transposed conjugate of H will also become 1 by root 2 1 1 1 minus 1. So here as dagger will becomes 1 by root 2 1 1 1 minus 1, but here h and h dagger is also same, but we have to calculate h dot h dagger. So this will become 1 by root 2 1 1 1 minus 1 dot 1 by root 2 1 1 1 minus 1. So here 1 by root 2 1 by root 2 will come outside and become 1 by 2, and inside the matrix multiplication here will be 1 1 1 minus 1 1 1 1 minus 1. So here 1 by 2 and 1 plus 1 2 1 minus 1 0, again 1 minus 1 0, and 1 plus 1 2. So yes, this will become 1 by 2 2 0 0 2, and the 2 2 gets cancelled, so it become 1 0 0 1. So h dot h dagger is equal to 1 0 0 1, which is also known as which is known as identity matrix. And here our property is true, so we can say that the H matrix is a unitary matrix. Similarly, here we have take H dot H dagger. You can also take H dagger dot H. Both will turn into the same result, which is I identity matrix. So same, it will be like same because here H and H dagger are same. So the dot product is also same. So it will also turn in an identity matrix. So here h dot h dagger equal to h dagger dot h equals to I. The property is true. So we can say h as a unitary matrix. So now we will talk about the importance of unitary matrix. Unitary matrices are important because they preserve the norm of the vector, which is crucial for probability conservation in quantum mechanics, and they are fundamental in quantum computing for representing quantum gates. So unitary matrix plays a very important role in quantum computing and in quantum mechanics. So this was all about the unitary matrix. Next, yes. So this was all about the video for my quantum computing teacher assessment 2, and I have covered all my topics such as eigenvalues and eigenvectors, Hermitian matrix, unitary matrix, and the importance of Hermitian matrix and a unitary matrix. So this is all about my video. Thank you.